In this video, I'll explain the mechanics behind whatever we did in the other video, which allows encryption and decryption to take place. I'll explain the role of the different functions and the reason behind their complex structure. By the end of this video, you should be able to change the code to suit your interests. For example, have a different separator, something other than a comma. Let's begin. So the first thing to understand is the reference list. You can understand it like a dictionary. It assigns each character a code. For example, the code for A is comma 1, the code for B is comma 2, and the code for C is comma 3. So if I wrote A in the interface, then that returns as code, which is comma 1. Likewise with B. The separator shows where one character in the encrypted text ends and where another character begins. This helps us to decrypt the text. There are two of the same columns in here. Why is that, you might ask? Well, it's because when we decrypt and encrypt, we use the VLOOKUP. During encryption, we enter a value that is stored in column A, then the VLOOKUP function returns its corresponding code from B2. During decryption, it looks up a value in column B and returns its corresponding character from column C. In simple words, the VLOOKUP function always returns a value on the right, not the left. So when we decrypt, it can't look at column B and return a value from the left, which is column A. That's why we made column B the first column, and thus made C the column where the corresponding value lies. If I type ABC in this cell, the problem is that it's going to give me an error. That's because a BC is not defined in my reference list. So we need a way to extract text character by character. For that reason, we use the mid function, and we nest it inside the VLOOKUP function. Now, it doesn't give us an error. When we want to extract the next character, we can just change the second parameter of the mid function, like this until all characters are encrypted. And that is exactly why we numbered the if functions in the other video. We were not numbering the if functions. Rather, we were just programming it to encrypt the next character. If I type 2 characters, then I need it to display the encryption of both characters. For that, we create a duplicate of the VLOOKUP and change the second parameter of the mid function so that it extracts the next character. To join the code of each character, we use concat-n8. Now it can read 2 characters. But here's the problem. If I delete 1 character, it gives an error. That's because we have more VLOOKUPs than the amount of characters. So to avoid this error, one could keep the number of characters equal to the number of VLOOKUPs. But that's tiring and inefficient. To circumvent this problem, we use the if function. The if function will execute another VLOOKUP if you add another character. If you have 2 characters, then 2 VLOOKUPs. And in order for it to know how many characters there are in a cell, we use the len function, which counts the number of characters in a cell. We nest the len function inside the if function, and we nest the VLOOKUP inside the second parameter of the if function. And this is what our encrypting code evolved into. From the simple VLOOKUP into a complex bug-free code. When we decrypt the encryption, we need Excel to extract the text from one comma to another. That extracted piece of text will be looked up in the reference list. To extract text between commas, Excel needs to know the position of each comma in the cell so that it can extract text from one to another sequentially. To find the position of the comma in the cell, we use the find function. It has 3 parameters. The first is the one that you are finding, which is the separator, in my case, a comma. The second is the cell in which you're looking for the comma. The final parameter is the position number from where it will start looking for the comma. In this specific example, it will start looking from character number 1 onwards till it finds the position of the comma. In this example, we modified the third parameter so that it continues to look for the next comma. F2 shows the position of the latest comma found in the cell. And this specific function will show the position of the comma that comes after the one referred to in F2. If a comma isn't found, then you get an error. Let's move to decryption. We definitely will use a VLOOKUP here too. But before that, we need to find how to extract the digits from one comma to another. We need the mid function for that. I wrote concatenate because it'll be needed to join the characters. Okay, so let me show you guys something. If I make this 2, it will extract the first 2 characters, the comma and the digit. That's fine. We want it to do that. But here's the problem. If there's 2 digits now, then we need it to extract 3 characters. That means we need to change this parameter all the time, according to how many digits there are between each comma. That's inefficient, especially if we have a lot of characters. To automate this process, we tell Excel to subtract adjacent cells in the separator finder. The difference between the greater value and the adjacent smaller value gives us the number of characters that need to be extracted to be looked up in the reference list. Let me duplicate this function. Now let's look at the second parameter. This refers to the position where the character extraction will begin. We need to start the extraction when a comma starts. Since the cells in the separator finder find the position of the comma, we tell Excel to refer to them when choosing where to start the extraction. Let me try to extract the comma from this cell, and I'll refer to the cells in the separator finder. We get an error. That's because we referred to G2. If there's an error in the cell we refer to, then our mid function will give us an error. This is a problem because our whole decrypting code will give us an error. Unlike the mid function, the count function doesn't give an error if it refers to a cell with an error. So we use the count functions in the if function to test if there's an error, and that allows the decrypting code to execute a command instead of showing an error. The secondary count function checks if there's an error in the following cell. The primary count function counts how many cells don't have the error. The number of cells that don't have an error indicates the number of characters that are encrypted. If we look at the decrypting code has a pair of each function. The first set of the pair are called the primary functions. The second set are called the secondary functions. Now let's compare each. The primary mid function extracts the characters depending on the positions of the commas. The secondary just extracts all the remaining text. It has a 3 because the longest character code comprises of 3 characters. The primary count function counts how many error-free cells there are, which corresponds to how many characters are encrypted. The secondary count function checks if the following cell has an error or not. The primary if function executes the secondary if function if there's texts to decrypt. But if there's nothing to decrypt, then it stays blank instead of giving an error. The secondary if function executes the primary VLOOKUP if there's more text to decrypt. But if there isn't that, it executes the secondary, which contains the mid function that doesn't refer to the error cell, which prevents an error. This is the end of the explanation video. If you were paying attention, then the complex nested functions are no longer intimidating for you. Until next time, we'll meet again soon. As always, thanks for watching.